Hello friends, a very warm welcome. Today we'll discuss about a very interesting and commonly talked topic, that is sockets. Myself Sanjay Kumar Das, a technology expert with more than 10 years of experience. I welcome you to my channel Canny Information Center. Let's begin. What is a socket? Socket is basically a medium of inter-process communication or sending a message from one application to other application over the network or within the computer between different processes, right? Now let us understand more about it. How does it goes from one application on a system to other application on another system? That is, by the IP address, it is going to reach from one computer to another computer. Now in that two computer, there could be multiple applications running. How would it identify those two applications inside that computer? For that, there will be a unique port number on each of the computers assigned to them, right? Let's understand this more with the help of a real-time example. For example, somebody has posted a letter on your address. Now the postman is going to see that address that is mentioned on that postcard and come to your home, and then it will see the name mentioned in that postcard and see the ID card of the person inside that home and then deliver that to you. Now how would you relate this example? Now that address that is mentioned on that card, that is the IP address of the other computer where it wants to go. Now once it reaches that computer, it needs to see an ID. So that ID is the port number of that application to whom it has to deliver that packet inside that computer. So now this IP address and port number are two things that are needed for a packet to be received by application on the other end of the computer. I hope you understood the concept of socket. Now let's go a little bit deeper. Sockets are basically of two types. One is a raw socket, one is a normal socket. So raw socket is present at the very bottom layer of the OSI layer, that is just above the physical layer. So that whenever you sniff any packet from the raw socket, at that point of time, none of the header will be extracted and you will get the complete packet data as it was sent from the server or from the other end. Now, normal sockets usually lies on top of transport protocol. So whenever you sniff any packet in normal socket, you will see only the data part after extracting all the necessary headers of Ethernet, IP and transport layer. Now there are two types of normal sockets, that is TCP socket and that is UDP socket. Today we will discuss in details about the TCP socket with the help of an elaborative example. For our example today, we will take a Linux machine named Ubuntu. You can take any kind of a Linux machine for this exercise. So before starting, I would like to show you something. If you go to your browser and type in google.com, you'll get the home page of Google. So what happens behind the scene is your browser is a client and it requests to the web server, that is Google web server, for sending the page, and Google web server sends that page to you, right? So now your browser is a client which sends some kind of data to the Google server. Let's simulate this using sockets. So internally this browser is using kind of socket to communicate to the Google server. Now instead of using this browser, let's code the client program in such a way using socket that we can send the same data to the Google server and that server should reply back with the home page of it, right? Let's write a client program. First let's list down or write down the header files needed. Now we have added the necessary header file required. Let's start with the main program. Integer main. Now the first part of this program is you need to create a socket. Let's write the necessary variables and then create a socket. Int sock fd. So here while writing, I would like to reiterate so that socket fd is basically every socket is identified by an FD. So internally FD is basically an identifier to identify a socket. So we declared a sock fd which identifies a socket. It is a file descriptor internally, and sock addr in is basically used to store the server information like IP address, port number and IPv4 or what kind of communication we are going to do, right? And we will do character message. This message is what we will send to the server, and then this server reply, you can say server reply, this will use to capture the reply that we will get from the server. Now let's create a socket. Sock fd equal to socket API, and let's fill in the parameters for it. First parameter is AF underscore INET. This means we are going to use this socket for IPv4 communication. Then your browser actually initiates a TCP connection to the server before any data gets exchanged. So for TCP connection we use the second parameter as sock underscore stream, right? And what kind of data you want to receive from the server is mentioned here. That is 0 is IP proto. There are different kinds of data that you can receive, so I have used 0. Now validate this socket. Now part 2 is configure the server address to which you want to connect and on which port number. Let's configure it. As I have defined sock addr in server, so this server dot syn addr dot s underscore addr equal to inet addr of. So here you need to give the IP address of the Google so that it can be converted into the understandable format of saddr. How do you get to know the Google's IP address? You just ping in another terminal, ping google.com, and here you got a response. If you see here, you got the IP address of Google. So this same IP address you give here. Now you said on which port number you want to send that information to Google, or on which port number you want to connect to Google. Syn port equal to HTONS, because we are going to send this port number which is a 16 bit or 2 byte value. We need to send it in a network order. That's why we used H2NS. And on which port you think your browser send the data? Obviously port 80, that is HTTP port. We'll use the same port 80. Now server dot syn family is equal to AF underscore INET, which specifies that I am using, or it is just to let server know that this is for IPv4 communication, right? Part 2 is done. Now part 3 is basically you need to now connect to the server, because you have now configured the server details, right? So now if connect, you use this connect API, connect sock fd struct sock addr star ampersand server size of server is less than 0. If that is the case, then put as connect failed and exit. If connect passes, then you print put as connection, or you can say simply connected. Now what is the use of this connect API? Connect API does two things basically. First thing, it initiates the three-way handshake of TCP, and second thing that it does is it stores the server information, right? Next, now it is in connected state. So connect actually started this three-way handshake, and once the handshake is over, connects gets successful. Then now it is in connected state. Now what is left from a client perspective is you need to send some data, you need to receive some data. So here your browser send some request to the server. Okay, let me craft that request for you. That is okay, here it is part 3, now it is part 4, that is craft a message to send. So here message equal to get http/1.1 sorry 1.1/r/n/r/n. So this particular string is used for requesting a home page of a server. So when we send this command to the server, a server, then that Google server is going to reply back with the home page content. Now we'll send this message to the Google server. Send to whom? Socket sockfd message strlen of message, and fourth argument we do not want to give any additional argument, 0. If send fails, if send fails, then we'll just put a message saying send failed, and we'll just exit or return -1. If it doesn't fail, we'll put data sent. Okay, now we have sent a request to the server. Now we will wait for a response from the server, which is part 5. Receive response from server. If we will use receive receive function, receive sockfd server reply, that this is the thing that we have kind of declared above, reply, and what is the size of it? 2048, and no additional data we need to provide here, and then less than 0. Now if receive fails, we'll just put up a message saying receive failed. Isn't it simple? Failed, right? And we'll just return -1. If we received some data and if it doesn't fail, then we'll put received data /n, and we'll also try to print that data, server reply return 0. Okay, so we have almost written the complete client program for fetching a website homepage of Google. Now let's run this program and see. gcc-o client.c. Great, it compiled successfully. Now let's run it. Now let's run it. Now you see here, now the client got connected to the Google server using the IP address and the port number that we configured, and then we send the data, that is the request, and whatever we receive we print here, that is HTTP OK, and this is the home page of Google that we are printing here. Instead, if we would have printed this on a browser, it would have shown you that Google home page. Okay, now we are pretty much familiar with the client functionality. Now since we cannot do any changes on the Google server, so why not write our own server program where the same client which we have can connect to our server program. So let's start with the server program. Let me copy the client program to server so that initial few part is same and rest will modify. Since it was a client, it has to connect to a specific IP address, but in case of server, that is not the case. So here what you need to give is in ADDR any. That means server can listen to any kind of connection from any IP address. And since we are using Google server, we had used a standard port number, that is 80. So in order to keep it clean, let's use a unique port number, that is for example 9999. Okay, and SYN family will leave it as INET, and client then connect to that port number. So client has to connect to which port number? That is 9999. Let's modify that client code to connect to 9999. 9999, and we had used earlier Google IP address. Instead of that, what we have to use now? Our own system IP address, that is local IP address is 127.0.0.1. Fine. There is no other change required on the client side for now. Okay. Now what is the next part in server code? We need to bind this socket that we created to this address. Now this socket is independent, it has not been bound to any IP address. Now in this case we have to bind this to this IP and port. So now we'll bind this socket FD to IN ADDR any and port number 9999. Now we'll call an API called listen, which is essentially to set up the number of maximum connection that can happen simultaneously. So this number 5 means if simultaneously there are like 100 connections, at max 5 backlog connection can be handled, or 5 connection can be handled by keeping it in some kind of queue, right? Now coming to the next part, part 5. So here bind and listen has been set up, everything is done. Now we will wait for some connection, right? Accept, or we can say waiting for connection. So how do you wait for connection? We wait for connection using an API called accept. So it is like, so what we'll do is will new sock, right, new sock equal to accept so this C should be a long unsigned long integer. That's why we had to kind of store it in separate variable and send it here. Now let's understand here. In case of client is always going to send request to a particular IP address and particular port number only once, right? There cannot be multiple connection for the same IP address and same port number from a particular client. That's why this SOC FD is enough to take care of that connection. But from a server perspective, if there are hundreds of connections that are coming, is the same socket FD going to take care of all the connection from the client? No, right? That's why this socket FD that we create using socket, this socket FD will be used to listen for different connections. Once a client tries to connect to the server, then in this client structure it will have the client IP address and the port number. So along with the server IP address and server port number, client IP address and client port number, it will generate a new FD for tracking that particular connection. So if there are 100 different clients that are trying to connect to a server, then 100 new FDs will be generated. And further, for any kind of communication with that client, this new SOC is going to be used for sending the data and receiving the data. So now we'll put some safety check. Now it is in a established state. So now there is another thing that you need to understand here is, in case of client, as I said, the connect is going to start a three-way handshake, and this connect is actually going to start a three-way handshake, and this accept is a blocking call, and it will only get successful after that three-way handshake gets over. So after this accept call, now the connection is made, and what is remaining here is you can send any data or you can receive any data. That is what is remaining. So let's try to send some data. That is part 6. Send data, for example. Now since socket FD is just like a file descriptor, we can use a write API to write to that socket so that it is received on the client side. Write new SOC message strlen of message, and we'll just return 0. So in the client program, if you see, client is sending some data and then receiving some data. So anyway, we have not written the code to when the client sends, we are going to receive. So we'll just discard that, and the client is going to receive something, and then whatever client receive, it will just print it in its terminal. So here the server is sending hello client. So this is what is going to be printed on the client. Let's run these programs. GCC-O client was already compiled. Let's compile it again. Client.c GCC-O server.c. It also compiled successfully. Now we'll run server here. Bind is successful and it is now listening for connection. Now let's run client from different tab /client. You see, hello client, I have received your connection is what is sent. But whatever client sent the data, since we have not written that code in the server, that's why we didn't print anything. But here in server it prints connection accepted and it closed. Now think of the scenario, whenever you open your browser, you connect to a server only once as per your need, then at some point of time later probably, but the server, in order to serve to the clients, it has to be always live. That's why that server has to be always running. But now in our case, the server, once it sends some data to the client, after that it exits. Let's make it little bit real so that it can run indefinitely. How do you do that? Let's make it while. Now it's an infinite while loop. So now let's compile the server. We didn't do any change in the client, so only we'll compile the server. and we'll run this server. It is listening for the connection. Now when we try to run the client, it ran once client and it again ran. So that means the server is indefinitely alive and it is able to serve all your connections. You see, there are 4 connections made and 4 connections were served properly. Now think thousands of clients are trying to connect to the server at the same time. So in this while loop, if there are like lot of code written to serve a client, do you think that is an efficient way of doing? Obviously no, that is a very bad design. For that, what we can do, we can use a threading model. There what you need to do is that once you receive a connection from a particular client, you create a thread and offload that work to that particular thread to take care of processing that request of that particular client. So if 1000 client comes, you just create 1000 threads and all the threads are asynchronously handling the request from the clients. Let's modify our program to handle that. So in order to implement this thread, we will include pthread.h, right? What else? We'll introduce a new pointer, new sock p. I think rest should be fine. Let this while loop be like that. Let's remove this thing. Connection accepted is fine. New sock p that we declared, we'll allocate memory to it. It is of type integer, so we'll typecast it to integer star malloc size of integer. Now star new sock p equal to new sock, whatever is returned by the accept call above. Now we'll declare a pthread underscore t process connection. Now we'll create a thread. If pthread underscore create ampersand process con comma no. Now we'll write a function name. So when the thread is created, at that point of time a new function will get called. This is the name of that function, that is connection handler. And what is the argument that we are going to provide to that connection handler is void star new sock p, that is the new socket fd. So if this less than 0, okay. Now while processing certain activities for the client within this function asynchronously, this main program should not exit before this has finished. That's why we'll wait for this connection handler to finish. For that we'll do pthread underscore join process connection, and will not specify any argument. Okay, so that seems fine. Now we'll write the definition of the connection handler. Void star connection handler void star socket descriptor. Okay, now here since we passed the new sock as an argument, we'll typecast it first to int sock equal to star int star socket descriptor DESC read size. I'll tell you why I took this after some time. Character client message 2048, this we took to receive whatever client has sent, and character message 2048, hi client, I am your connection handler. I'll just okay. Now we'll write on the new sock FD, that is sock comma message strlen of message. Now what we'll do is we'll receive something from the client and we'll write the same thing to the client. While read size equal to receive sock comma client message, what is the length, 20480 greater than 0, write the same thing back. Sock client message comma strlen of client message. Right. Now since we saw here this is a dynamic memory allocation, so it's our responsibility to free this pointer. We have allocated here. Now we are passing this responsibility to the thread to free of that memory. So at the end we'll free of that memory, that is free socket descriptor, return 0, or we do not, that's a void pointer, so it's okay. Now since this connection handler is written after main function, we need to declare the declaration of this function above, void star connection handler void star. Fine. Now you see here that this looks good from a real scenario, where if there are multiple accept calls or multiple connection coming, each connection is being passed and a new thread is getting created, and that thread is actually doing all the task for handling that connection. Let's run this, let's compile. Okay, there is some error, 73:73. What did we miss? Okay, this we didn't want this. Anyway, there is one line inside while, so we don't need this. Open and close brackets. Okay, p thread. Okay, we need to link this to lp thread. Awesome. So now the server is ready, bind is successful, it is ready to accept multiple connections. I'll run this. I am a connection handler. See, this is coming from the thread that is assigned for each client as and when they come. The client handler assigned, and then client got disconnected. Handler assigned. You seeing this? Right. Now let's see something more in the server code. For example, you are not freeing this FD. For example, we'll put a while one indefinitely and will stop. Whenever a client connects to this server, it will never finish because there is an indefinite while loop here. Now I'll compile this thing. I'll run this server. Now what is the state? That server has created a socket and it has bind it to the address, and now it is waiting for connection. So there is how many FDs created here? By default for a program, 3 FDs get created. One is the input, standard output, and error. How do you see that? For example, you do a ps-ef grep server. Now if you see, your server program is running and the PID of it is 10,022. Now go to the process cd/proc/10022. Inside that you go to the FD list. If you do a ls here, you see every program is having, this is standard input, this is standard output, and this is standard error. So apart from this 3, next whatever comes in is user defined, and this 3 is the socket that you have created. See, if you do a ls7l, you see the socket that you created. Now let me just run the client once. It ran the client once. Do you see this? Again one more got created. Why? Because in the server code, when the accept call got called or got triggered, it created a new socket FD, and that socket FD is not released yet because I have put a while loop here. That's the reason you are seeing this is the base socket on which it listens, and this is the socket that got created from the accept call, right? So I hope with this example that I explained over the computer, it was pretty useful for you in understanding in a better way how the socket, or mostly the TCP socket, worked. Now in the next video we will talk more about UDP socket, and in the upcoming series we will also talk about the raw socket uses and many more different things on sockets. If you want to know more about a certain particular aspect of the sockets to help you understand that, please mention in the comment section. Also, if you want to know something more about the technological field that you are not aware of and you feel that my explanation is really helpful with the help of examples, so please feel free to write down in the comment, and all your suggestions should be really appreciated to improve my video. If you like this video, don't forget to give it a big thumbs up, share it as much as possible. Please subscribe it if you have not subscribed it yet, and don't forget to hit the bell button.